Okay, so the first step is the most important step for the power series. Okay, first step, after we write our y double prime, y prime, y with the power series term, we put back into our original ODEs. Then the first step is work on all terms to shift the exponential part to the highest order, which is x to the m for our case, right? We have the term is x to the m minus 2 and x to the m. We want to shift all the term to be x to the m. And also, we want to force the sum part, so the sum part, to begin with m equals to 0, okay? Because we have some term that the exponential part is not x to the m, so we need to shift those parts, those terms, and also at the same time we want to force the sum part is all begin with m equals to 0, okay? And how we do that? The previous equations we have, okay, we have this one. So this is our previous equations. We have the term which is x to the m minus 2. We have x to the m. And right now we are all begin with m equals to 0. Okay. So we need to do something for the first term in order to shift that x to the m minus 2 to the x to the m's term. So the first term, term 1, in our example, that sum from m equals to 0 to the infinity m minus 1 a to the m a times m x to the m minus 2 term. And how we do that? We can substitute where the p equals to m minus 2. Then that means my m will be equals to p plus 2. Okay, we will replace the m minus 2 to a p. So after we substitute p with m, what we can get from the first term. So the term 1 will be equals to, if my p equals 2 and minus 2, then p start with 1. P start with minus 2 to the infinity. And then the m will be equals to p plus 2. So p plus 2 times p plus 1 times a p plus 2 x to the p's term. Okay, then we can expand several terms and see whether we can shift that to the exponential part to the x to the m. Okay, so let's start with p equals to minus 2. If my p equals to minus 2, this term will be equals to 0. Then we don't need to worry about the rest. So that will be 0. Okay, then p equals to minus 1. P equals to minus 1, this term will be equals to 0. We don't need to worry too much. 0 plus, how about p equals to 0? P equals to 0, this term will be 2, this term will be 1. Okay, then this term will be equals to what? A2, right? So a2x to the 2. So what we can do is p equals to 0 to the infinity, right? So p plus 2, p plus 1, a to the p, sorry, ap plus 2, okay, times x to the p. Because all the other term will follow this format, okay? Then what we get? We get the sum from minus 2 to infinity actually is sum from 0 to infinity, p plus 2, p plus 1, a p plus 2, x to the, okay? And that is from p equals to 1. We can just go back to our term where we just need some integers from 0 to infinity. We can replace by m again. So m from 0 to infinity, m plus 2, m plus 1, am plus 2, x to the m. So right now we shift our highest term to x to the m, and we start with m equals to 0, and that is satisfied about what we are trying to do. The goal is exponential part is x to the m. The begin part of the sum is m equals to 0. So we did this here, okay? The next part is we just need to put this term back to our original sum, okay? So we just need to replace this first term with here and come back to our original third step. So the first step is substitute this term back into ODEs. And let's see what we can get. We have sum from m equals to 0 to infinity, m plus 2 times m plus 1, a m plus 2 x to the m term. And all the other terms we can just rewrite like before. So minus m from 0 to infinity, m times m minus 1, am x to the m minus 2 sum m from 0 to infinity, m times am x to the m plus 2 times m from 0 to infinity, am x to the m equals to 0. All the other term we don't need to change because all the other term is satisfied about our first step. Is that all the term with exponential part is x to the m, and all begin sum with m equals to 0. Only the first term need to do the substitution, okay? Then we can just put all the x to the m term together with the coefficient. It's sum from m equals to 0 to infinity. So we can put the coefficient into a parenthesis term. So m equals to 0 from the sum from m equals to 0 to infinity is all the common part from these equations. X to the m